right, for 3.11, related rates, we have a problem from our textbook where we have a inverted conical water tank with a height of 12 feet and a radius of 6 feet, draining through a hole at the vertex. And it says it's draining or an outflow at a rate of 2 feet cubed per second. So remember, this 2 feet cubed per second is an outflow, or we're draining. We have to think of it actually as a negative rate of change. So then it says in our book, we see the figure, and when it says, what is the rate of change of the water depth or the height when the water depth is 3 feet? So it says here I'm going to have dH dt is what I'm looking for when the height is 3 feet. Remember, when doing related rates, I have a picture, I have given information, and I have what I'm looking for. And usually it tells me at a certain point, what am I looking for at this rate of change? Remember, we cannot plug in the h equals 3 feet into any kind of formula yet, because that would like freeze it or hold it or lock it into place. It becomes a constant, and it's not. I want to know what the rate of change is at that time, so I'm not going to do any substitution yet. So I need a generic or general formula for a volume of a cone. It should be 1/3 pi r squared times h, the height. Now here's where our situation is. We're looking for dH dt, and I have two variables on my right-hand side of the equation. I'm given the rate of change of the volume, so dV dt, and I have on the other side two variables. I want to get it down to one variable, and they didn't ask me anything about the radius of the water. They only gave me the radius of the cone of the tank. So from here, I want to go ahead and substitute in R with some kind of H. So what I want to do then is use similar triangle situations where I have radius over the height situation of what I'm looking for, and then I'm going to compare it or equal it to the similar triangle of the given information where the radius was 6 of the tank over the height of 12 of the tank. And then from here, I'm going to solve for R so that I can substitute it into my formula. I should have R equals H over 2. I simplified the right-hand side and I multiplied both sides by H. So now I'm going to go ahead and substitute in for R into my formula, the H over 2 for R. So I'm going to go ahead and say my formula really is the volume is equal to 1/3 pi over H of H over 2 squared times the H, substituting for R. Simplifying it through, I have pi over 6. I'm sorry, no I don't. I'm squaring the 2, so I have 4. I should have pi over 12 times h cubed equals my volume. From here, I'm going to take the derivative of both sides with respect to t, and then I should have dv dt is equal to, I'm going to bring my exponent using my power rule. And then I can simplify this expression in saying it's really pi over 4. And I'm going to go ahead and substitute that in. All right, from here, I have to do the chain rule because it was with respect to t, so I'm going to have times dH dt. I finally have it where this dH dt is what I'm looking for. I'm going to solve for this, or if you want at this point, I could substitute in what values I know from the given information and then solve for dH dt. That is completely up to you. We have that we're going to plug in for h a height of 3 feet, and that we had for the rate of change in the volume was a negative 2 feet cubed per second. So I'm going to go ahead and substitute in negative 2 feet cubed per second is equal to pi over 4 times 3 squared times the dH dt. And then from here, I can go ahead and solve for dH dt. And we should get that it's a negative 8 pi over 9 feet per second as our final answer.